Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products. Hey everybody, welcome to Beyond the Bench, Hardware Stories That Matter. I have a very interesting and fun guest for you all today, Keenan Johnson, founder of Breadboard Foundry and Ribbit Networks. Keenan, thanks for jumping on the show.
Hello, thanks for having me, Bill. It's so great to meet you and be on the show today.
Yeah, absolutely. I've been following your work for a while on LinkedIn, and it seems like you've got your hands in a lot of different areas. But what jumped out to me immediately, or what got the initial interest, was the work with Ribbit Network. Would love to just hear a little bit more about that project, that ecosystem, and what's going on there.
Yeah, Ribbit Network we're an open source project that builds hardware and software for climate sensing. It's sort of my passion project, and I guess it's sort of the most public kind of interesting embedded engineering topic that I've got. And I've spent my career kind of doing all kinds of things. I worked on rockets very early and big robotic systems. But I really wanted to work on climate for a long time, and I've sort of been able to do that in kind of my professional career for a while. But Ribbit Network is sort of the main passion thing that I love, and it lets me play around all the nice embedded systems technologies, and it really connects with a problem that I care about.
So what is Ribbit Network?
Yeah, so we do a few things. Firstly, we design and build climate sensors.
Okay.
So they measure greenhouse gases and sort of other climate-related things. Climate change is so interesting because we, unlike most of our societal problems, there's no question about what is the cause of climate change. Mm-hmm. It's greenhouse gases. So that should mean, from a science perspective, it's so easy to think about how to fix it. We need to measure emissions and then reduce them. That's the very simple formula for climate change. Obviously, that's really, much harder said than done. Right. But Ribbit Network is sort of the project that I feel very passionately about to do that.
And so it's an easy to build network of sensors like how do people engage with it?
Yeah, totally. So if you're on video, this is one of the sensors. If not, you can go to our website and find it at ribbitnetwork.org. But we build these sensors. It's a 3D printed enclosure. We do it out of recycled plastic, which is cool. So, we publish all the designs for how to 3D print this enclosure. We've also got really good instructions for how you wire up the electronics, do the software stack that goes on this. So you can build one of these sensors and get credentials and plug it into our, open source fleet of sensors. It joins that. That's how you get firmware updates from us. It also publishes its data up to a data set in a database that we manage and make sure stays in the public domain. So you can look at the data from your sensor, hopefully learn something. And it's usually just a fun kind of learning experience, whether you are interested in 3D printing or electronics or perhaps embedded software, or how does an actual fleet of IoT devices work in the real world. Because I think our project is so interesting because there aren't that many examples of open source fleets that are like functional, like a real product. And so if you're on the learning journey and you want to see like, oh, what would it take to go from my like little Arduino project to a real product, you don't really have that many examples to like look at it. And so our project is so fun because we get to play with all those problems in the public domain and open source for a real kind of mission and purpose, which is fun.
And so what are the sensors that are on the device, and is it customizable?
Yeah, definitely. So that's one of the best things about being an open source project is, we encourage all the customization. Right now we have a CO2 sensor, which measures gaseous CO2, which is kind of the most interesting, complex sensor that we have. We also have humidity, temperature, barometric pressure, and then we have a GPS sensor to give us a really accurate altitude, interestingly. So we have a kind of a different use case for GPS than most people, which is that we care about the altitude portion of the GPS, which is kind of what most people don't care about. They just kind of want latitude and longitude. But for us, because gaseous CO2 mixes in the atmosphere so differently depending on the altitude, we really care about knowing exactly what the altitude is. So the GPS is kind of the best sensor that we've got for that.
And open source hardware, what does that mean? Like for those that are kind of into the space?
Yeah, so I think everybody has a different definition, but my definition is you have everything that you need, all the design files, all the instructions, where to buy parts, what parts are used, so that you could recreate that device 100% accurately on your own. So we publish all of that. So all the CAD files, for example. I think a lot of people would say if you just publish like STL files, that's not really open source because you can't really
not easy to
replicate.
Yeah.
So all the source files from the mechanical CAD design, all the electrical files, everything is there that you need to build this thing yourself if you would like.
And do you have any other animals that you are compatible with? Is there like a cow version, or is it, pretty stuck on the frog?
I don't know. Yeah, we sort of adopted the frog as our mascot. One, because it's fun. People like frogs. They're a good indicator species for climate because they're really temperature sensitive, and they gotta live everywhere around the world. So we've got lots of people who've built different kinds of frogs. That's one of the fun parts of the project. You can make different colors of frogs or add whatever accessories you want onto your frog. But I don't think we've had anybody do other animals, though maybe. We just finished a contest to do a solar-powered version of our sensor.
Cool. Nice.
And maybe that could be a different animal. Who knows?
You mentioned history and robotics and interest in energy in general. Is that how are these projects related, or is that just this is the background and you're doing some climate work, and then what do you Breadboard Foundry?
I think when I transitioned my career into climate, I started working on a lot of battery mobility things. So I was working on an electric aircraft startup. I've been lucky to do that and a lot of robotics things. I've done a lot of like big energy storage projects since then because I kind of had this knowledge in batteries and putting together really large battery systems. And all that work is really important and great. But I started, kind of noticing, I was like, okay, like this is good. Where there's lots of people working on, reducing emissions at the source. So a battery project or a generator project is like that. But a lot of times people don't know if they're working, basically. So like the big question is like, okay, we deployed this thing. Does it work? Or we added this battery pack onto our bus. Did that actually reduce the emissions? It's often not known. And so it just kind of became this hole that over time I just couldn't ignore anymore. And so like, okay, I want to work on that. The reason nobody else works on it is because there is no for-profit business model that functions. Because there's no, you can't sell the data, which would be the normal for-profit business model. And it's also sort of counterintuitive because like we want scientists to have the data. And so open source hardware is the most useful for scientists. So that's what kind of kicked off Ribbit Network.
Cool. Connect the dots for me a little bit. I'm not sure I entirely followed. So the efficacy of introducing batteries, right? You're saying, hey, we are or are not sure that this had an improvement on the overall system. Where like a lot of my experience in batteries and some of the customers we work with are building like battery management systems as a whole. And like that thing obviously works because it's like a battery backup, or it's like load shedding from a solar or wind farm or something like that. So like what is the use case where there might be some ambiguity here on the use of the battery?
Yeah. So if you imagine like a hybrid vehicle, right?
Okay.
It's got a gas engine and a battery pack. And that's really common in like a city bus, for example. And so we know that if you run the battery, that's less emissions than running the gas engine. But a lot of times it's kind of ambiguous. You have a hypothesis for how the system functions, in the real world, but how it maybe actually works in practice is a little bit ambiguous. And so sometimes people aren't sure, like, okay, if we adjusted, like, maybe the low voltage cutoff of the battery pack system on the bus, how does that affect how often the gas generator turns on? And what is the idling emissions of the gas generator? So it could be pretty ambiguous in the real world, I think, what the actual emissions impact of those systems is.
Interesting. Cool. And so what's Breadboard Foundry focused on?
Yeah, so like I said, a lot of my professional work is in consulting, building embedded hardware and software systems for big kind of climate projects. And I think I got tired of rebuilding a lot of the same software stacks inside of 1,000 different companies.
Likewise, yes.
Yes. I think so many software tools are not designed for hardware projects. They don't consider a lot of the things that you need to consider. And it's really frustrating to use them as a hardware founder. And so I have been through that many times, picking out all those tools. And I think I've rebuilt the same couple tools enough times that I was like, okay, I would like to not do that again. And so Breadboard Foundry is a small software studio that's kind of building a very curated set of tools for those hardware kind of companies.
Cool. And so what are those tools?
Yeah, so we have 2 of them right now, which are, I think probably a lot of your listeners will relate to this. If you're building like an embedded systems product or a hardware product, most of your time is actually not spent as a full team on engineering the product. It's around supply chain, for example, is a really common one. And so we've got one tool called Pretzel. They're all kind of bread themed, and Pretzel is a really simple tool that, you put your BOM in there, you put your lead times for products, and you say, okay, here's my order queue, or maybe that's an internal R&D queue for prototypes. What do I need to buy and when so that I don't spend over this amount of money in my inventory? And it sort of does that calculation and tells you what to do in kind of a very simple tool, which is, if you're managing that in a spreadsheet and it's starting to feel really obnoxious and you're making a lot of mistakes, but you don't want to pay 7 figures to a very large software vendor for that kind of solution, Pretzel is kind of the in-between slot for you, which I think is really great. And then the other one is called Souffle, which is a project planning tool. So if you're embarking on a hardware project, you want to have a plan of what you do. And I think there aren't really any good planning tools for that. There's lots of good execution tools like Jira or Asana or Trello, which are tracking as you're doing the project. But every great project I've been involved in went through a bunch of planning iterations first before they started. And so Souffle is designed to serve you in that iterative planning phase first.
And so what's the focus of planning at that point? Are you actually picking components, picking peripherals, or like what's the like actual detail?
Yeah, like that's a great example. Usually you're trying to figure out, okay, we could go with this processor, but it has a 40-week lead time. Or we could go with this one, which has a 20-week lead time. And so you're trying to figure that out, like, okay, does that matter in our project flow? Maybe this one is better, but the lead time doesn't work with the schedule. Or maybe we should a common scenario is a build versus buy trade. Maybe you're deciding to do a software package. Should we build that? We have to hire 2 engineers to build that, or we could buy it from this other company. Like, what should we do? And you're trading all of these, kind of like people, money, lead time questions to make your big technical architecture choices. And that's kind of like this messy process that you usually go through a bunch of iterations with to try to figure out what the right answer is. And it sort of is a tool that serves that.
And so, I mean, you've got a deep experience in robotics and hardware, and you're investing your time in solving the project management and overhead. What was kind of the jumping off point for to decide to really invest in this side of the solution?
Yeah, I think, I'm a technical person. I've spent a lot of my time doing technical work, and I still do. But I think there is a real lack of people coming up from the technical side who are kind of interested in the more people-y side of things, which I would say, like, manufacturing or project planning. Those are more people-oriented
Yeah.
things rather than technical things. And I have, found myself in management and leading teams a few times. And I find it really compelling and interesting. And it just seems like such an underserved uh, area, I guess. And I don't know. I find it just as interesting, I think, as the particular technical topics, because I'm so motivated to solve problems. And so I use technology as a tool to do that. And if I feel like manufacturing execution is the number one thing in my way, that's what
Yeah.
I would rather work on to get to the end problem state, I guess.
Hardware is so different than software. My background is in software development and came up through that
Yeah.
lifestyle, I guess, and agile and tester. It's like you can do everything on. We were using Pivotal at the time. That was the cool tool. But
Yeah.
you could do so much management through that.
Yeah.
But you didn't need to invest in the same level of resources on program management, QA, like supply chain. Like, who cares? I mean, it's AWS. It's just.
Sure.
Yeah, software is a little more reckless than hardware, and it's really important to have these moments in time where you can truly check in. Otherwise, you're going to just get clobbered in the last mile.
Definitely. Yeah, it's there's a lot of people who throw around this like agile hardware term, and that
Yeah.
works okay if you've got a very cheap product. I've mostly worked on very expensive products, and so it's just agile hardware is a fast way to bankrupt yourself very quickly if your project is very expensive. So it's yeah.
So what are the projects that Breadboard's working on right now? Are you 50-50 consulting and products? Are you looking to move more towards the product, or it seems like you really enjoy the hardware side of it too?
Yeah, I see Breadboard kind of as the complementary thing to a lot of my interesting consulting work or the work at Ribbit Network, which is all hardware focused. So I'm still kind of doing a lot of that work, but
Okay, so Breadboard does not own the consulting work either. This is like you have Ribbit here,
yeah,
Breadboard here, and then also Keenan's off doing
I guess
hardware stuff.
yeah.
Yeah.
Yeah, I've been consulting for a long time just as me, as a human, and Breadboard is just sort of this new thing. And I just see it as very complementary. I think, Breadboard is not designed to turn into a super huge, like, VC-backed company, because I think that doesn't serve the customers that we have. And so I don't know. I guess, I'm open to whatever possibility comes up next, but I try to just balance the three of them because I find that they all sort of synergize together. And yeah, I don't know. Just try to keep them all going at the same time.
Are your hardware projects local to the Washington area? How do you typically get your customers in consulting?
Yeah, there's a lot that are local in Seattle, Washington, where I live, but I'm super lucky to have lived and worked in quite a few places, and so they're sort of spread out, kind of everywhere. So
Yeah, there's a lot of I mentioned before we started recording the Seattle area. There's a lot of hardware focus up there. It's really interesting. What are you working on right now? Is there anything exciting?
Yeah, well, I just finished up a consulting project for a big fusion company. So Seattle is kind of the nuclear fusion kickoff place of the US for whatever reason. So there's quite a few companies up here that are doing nuclear fusion. So it was a really big like control system for a nuclear fusion system. I just finished a really long project with them, which is super interesting. It gave me all kinds of ideas about kind of what the missing pieces are for like big control systems, which have kind of been like PLCs. I don't know if you know that term. Is kind of like the dominant, standard and way of thinking in big control systems before that is sort of undergoing a little bit of a renaissance right now, I think, as embedded systems get much better. uh, yeah, and then I've got a few other kind of like really interesting small sensing projects, which are all
Cool.
kind of the opposite, right? They're about like how do we get as low power as possible and push battery life on a small device as
Yeah,
long
that's
as we possibly can.
the Ribbit. The Ribbit experience, I'm sure, is nice there too.
Yeah.
So tell me a little bit more about the industrial controls piece, PLC, definitely the dominant technology today.
Yeah.
What were you looking at? What are you bringing in? Where's there room for innovation here?
I think PLCs are really great if you want to have sort of like a closed loop system that sits, in an industrial environment. Maybe you've got like one screen, which is like, the HMI where an operator can start or stop it. The kind of reality of what most people want out of a modern control system is much more complicated than that. They want to be able to hook it up to a database and stream all the sensor data off into the database. They want to have user interfaces accessible from anywhere in the world with role-based permissions and logged in a modern software experience. I always think about when I worked on rockets, I worked on mission control systems a lot. And people want to feel like that is their experience, no matter what you're building, whether it's a hot dog making machine or a rocket control system or a nuclear fusion system. You want to feel like it's the same. You have the same level of information and control and sort of gravitas about that system. And a lot of the PLC kind of like old school control systems are not built with that context. So I think there's a lot of work happening right now where people are pushing embedded Linux real-time control systems into the place of where PLCs were, which is having growing pains for sure. But people really want sort of the ecosystem and the tooling that embedded Linux makes much easier, for example.
Are there any companies that you think are paving the way here, or do you think that this is more internally owned technology for a given like fusion company? Hey, we've got to build this stuff because there's nobody that's going to be able to do this to our spec in-house.
Yeah, there's definitely kind of a new wave of companies coming up. I think where the gap is there isn't really like a lot of good embedded Linux hardware for like that replaces the hardware of PLCs.
Yeah.
For example. So like there's so many interesting things that are happening. Like Backoff is one of the big PLC companies, probably like one of the top three. Most PLCs run on embedded Windows,
Yes.
which is end of life now. And so everyone's trying to figure out kind of what to do. And Backoff is the first one that says, hey, we have embedded Linux support, first class. And so I think a lot of people are buying Backoff hardware, using their embedded Linux distro, and then putting whatever software stack they want on top of that. And I don't know if there's a lot of people like yet kind of serving that niche on the software vendor side yet, but there's lots of options once you get off the device for like, InfluxDB or timescale
data aggregation and
the data aggregation tools are really good. And so there's kind of like, I think most people working in the systems are, they're just trying to glue those systems together in a really robust and reliable way, which is definitely a challenge.
Do you get terrified about thinking of people dropping like MCPs on these things and then having just like people vibe coding vibe coding is the wrong word, but just like with all the AI stuff and making it programmable, somebody's going to start dropping AI controls of these systems.
Yeah, but it's so interesting. Like I have worked on, control systems for a long time, and there was a project I was on for a really dangerous machine like 10 years ago. And everyone had it. I think AI in control systems has been around for a long time. It's always been a thing that people wanted to do. You can go read DARPA papers for like the last 40 years where people have been trying to like integrate whatever the latest open source AI technology they had was into control systems. and it's always really hard because you can't get the thing about all these control systems is you have to get to like 99% confidence that it's going to do
discrete
the right thing.
It's discrete versus probabilistic.
Yeah, and it is very difficult to test and verify any sort of non-deterministic system where you can't explain why it did what it did. It's very difficult to put that in a control loop. I think there is good precedence for like, okay, how do you use those kind of like analysis AI tools to give you thumbs up, thumbs down for a human then to make the call? And I think that will be sort of the nuanced rational way. And like I view LLMs and some of the new kind of AI tools as sort of the next evolution for that. If we can put those in the flow where you give human operators the thumbs up, thumbs down to make the right call, that can be a big win for a lot of systems, because there is too much data in most of these systems to like deterministically write a lot of algorithms for. But yeah, I think just throwing it into the direct control loop is a very tough, that's a big ask.
Yeah.
To do initially.
And you've got to have extremely strong guardrails in place. I mean, do you go to many like robotics conferences, or you ever?
Yeah, I stay in the robotics loop, and you can look at it like, look at the amount of effort that self-driving cars are putting in. It has taken us 30 years and hundreds and hundreds of billions of dollars, and we're maybe like right at the cusp of seeing autonomous cars kind of out in the world functioning, depending on who you talk to. Like Waymo and Tesla are doing it kind of with very like restricted guardrails and a lot of humans still in the loop. That's the scale of the effort that's in front of us. So I think if you were considering an AI in the loop control system, think about that scale of effort if you're starting off a project before you greenlight it.
Yeah. You span the gap in these two scenarios, control systems, embedded Linux versus Ribbit and RTOS. Where are you most comfortable? What are the types of applications you're excited about?
Yeah. Well, yeah, I think I've done more kind of classical embedded systems for a long time. So, just you got a microcontroller, it's blank. What do you do? Writing C was kind of where I started my embedded systems career, and I think that's where I feel the most comfortable. And I also weirdly feel like those bare metal systems are becoming more popular counterintuitively, because what's happening, I think, in cloud software is these systems are becoming really huge and complex and big, which is awesome because they're unlocking all kinds of new capability that you can do. But what that means is that vendor lock-in is increasing on the cloud side. And most kinds of problems don't need that, like kind of really complex sort of reasoning, or you don't need as much compute as you did. And microcontrollers are getting awesome, no matter what context that you have is. And so I think that what is happening is for a lot of the like more standard kind of embedded systems, I guess, where you don't need the best in class for everything on the compute side, more and more of those are going onto microcontrollers, because you can do really interesting things with battery and power and different connectivity layers like cellular or LoRaWAN, or Bluetooth has gotten like pretty interesting and good. There's all kinds of new mesh radios, which are awesome now.
Yeah.
The embedded, microcontroller space is becoming very, very interesting very quickly. I think in comparison to how it was maybe 10 years ago.
So, are you doing any of this Bluetooth to space stuff?
No, I haven't gotten involved in that, but I know there's a lot of like direct cellular kinds of things where like you've got different 5G radio waves coming down. I haven't done any of the Bluetooth to space stuff yet.
Yeah, very cool. Well, awesome. Well, really enjoyed the conversation. Really appreciate you coming on. Are there any ways that we can help you on the show? Anything you'd like to advertise? You hiring? You looking for new projects?
Yeah, well, I think, if any of the problems I talked about, specifically like, pretzel or souffle, that like, what do I need to know to build and when? Or like I'm planning a project and it's difficult in the hardware space. If any of those things sound like they are related to what you experience, definitely come find us at Breadboard Foundry, or, shoot me a message or email. Hopefully I'm easy to find on the internet. I think we're always looking for new customers there. So we'd love to talk to you and figure out what your problems are.
Wonderful. Well, thanks so much for coming on, Keenan. It's great to meet you, and we'll have you back this time next year,
definitely.
something like that. Yeah.
Yeah. Thanks, Bill. So great to meet you.
All right, everybody. Just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.